Okay, today we're going to cover Unit 7, Notes number 5. So today we're going to talk about our calculator application problem. Now this is going to be, I'm going to show you how to do it on Desmos. However, it's going to be kind of tricky. We're going to do it more with the graphing calculator in class. So first one is kind of review. It says use a table to graph the function f of x equals 1/2 times 2 to the x and identify its key characteristics. So we have to create our table, and then we want to go and type it into Desmos and graph. So I'm going to be using Desmos whenever I do these videos because that is how it's going to be easiest for me. So we're going to have 1/2 times 2 to the x. And then again, if you hit the gear button and then hit the table, it'll give you your table. So we have 0.125, 0.25, 0.5, 1, and 2. So we're going to graph those points on our line. So negative 2.125 is going to be super close to 2, but not quite. And then we're going to have it a little bit higher. And then at 0, it's at 0.5. Then 1, 1, and 2, 2. So those are going to be my points. And then drawing my exponential function, it's going to graze at the x-axis and then go up. Make sure you have arrows on the end of your line. So our y-intercept on this one, and we can look on our table, is 0, 0.5. The horizontal asymptote, remember that's the imaginary line that it never crosses. So that would be y equals 0. This one is going up. So it is growth. If you guys remember, our domain is always going to be all real numbers. And then our range, it's at y and going, it's at y is 0 and going up. So it's going to be y is greater than 0. So let me know if you guys have any questions over that. And then the next one says, what is the y-intercept? That would be 0, 0.5. And that was on our characteristics list. So you can also look back at that. Okay, so now going down to graph, using a graphing calculator and sketch a complete graph and state your window dimensions. So this is where we're going to plot our graph. The only two things you need to label are your y-intercept and your horizontal asymptote. This x is going to tell you your dimensions. So right here, you'll put your y max. And then below, you'll put your y min. Then over here, you'll put your x max. And over here, you hit your x min. So this will be a lot easier on the graphing calculator because we are going to normally have those be either negative 10 or 10. So let's graph this function in our calculator or in Desmos. So we have 5 times 2 to the x. And what was it? Minus 7. Okay, so this is our graph. So this one we're actually going to have to zoom out a little bit because we want to see this horizontal asymptote, which it looks like it's getting super close to negative 7, but never touching. So if we can say, we can probably use our Windows dimensions as the negative 10, 10, and 10. Because that'll give us all of our information. So we're going to do 10, 10, and then the mins are negative 10 and negative 10. So if we look just with those dimensions in this, and I can't really... Okay, there we go. So there I have my dimensions of 10, negative 10, 10, and 10. So our graph grazes at negative 7 and then goes up. It crosses at 0, negative 2. So on our graph, we're going to have our horizontal asymptote, which is y equals -7. And then the y-intercept is going to be at 0, -2. So that means this line it needs to be a little bit lower, but grazes this and then goes up. I cannot draw that very well today. So it just has to be a sketch. So our y-intercept was 0, -2. The horizontal asymptote was y equals -7. This one was going up, so it is growth. Our domain is all real numbers. And then our range, it's at y is -7 going up, so it's going to be y is greater than -7. Okay, let me know if you guys have any questions on that first problem. Going on to the next one, we're going to do the same thing. So we're going to plug this into our calculator. I'm going to kind of start by, oh goodness, by sketching. So my x, y, or you guys know what I mean. Y and then our x. Okay, so we have y equals -12 times 1/3 and then plus 2. Okay, so this is our graph. So if we keep it in our, we can keep it in our -10 and 10 dimensions because our y-intercept's at -10. And it looks like right here it gets super close to y equals 2, but it never crosses. So keep our dimensions the same. So what did we say? It has a y-intercept down here at the bottom at 0, -10. And its horizontal asymptote is at y equals 2. So our line, I believe it goes down. Yep. So it's going to start up here and then go down. That is really bad picture. Okay. So it has to look similar, you guys. I know it may not look exact. Heck, mine doesn't look exact by any means. Okay, so on this one, our y-intercept is 0, -10. We already classified that. Our horizontal asymptote is y equals 2. Our domain, like we said before, is always all real numbers. So this one is at y2 and it's going down, so it's actually going to be y is less than 2 as our range. Okay, let me know if you guys have any questions over the calculator problem. We are going to move on to the back page. So on the back, we kind of have our first one's kind of a review problem. It says determine if the following points lay on the graph. What I want you to do is I want you to plug this into your calculator and draw me your table. So I'm going to do my x, y. I'm going to do -2, -1, 0, 1, 2. I'm going to have 0.5. There's nothing on the front. And then what was the end? +5. Go to my gear, hit my table, and I get 9, 7, 6, 5.5, and 5.25. Nine, 7, 6, 5.5, and 5.25. So does 5.5 lay on the graph? Yes, it's right here. So is this a solution? Yes. -2, 9. Oh, look, that also lies on the graph. So that is also a solution. So that's all you have to do for that one. If you draw your table, that is showing your work, and you just have to tell me yes or no. Okay. Next one, it says identify the transformation of the graph when compared to the parent function y equals 2 to the x. So if we think about y equals 2 to the x, you guys can always graph this. it is going to look something like this. So we know some changes happen. First, we can see that it reflected over the x-axis because it went from shaping up to going down. So the first one we can see is a reflection over x-axis. And then we have to figure out what is our a value. To find the a value, our a value is our y-intercept. So, but we have to make sure whenever we say our y-intercept, it has to be, our horizontal asymptote has to be 0. So on this one, our horizontal asymptote is 0. So if we go down here, this is our y-intercept, which is 1, 2, 3, 4, 0, negative 5. So that means that my a value equals negative 5. Well, if you guys remember, if there's a negative, we already did the reflection. And if it's a whole number of 5, it's going to be a vertical stretch by 5. Now, if that was a fraction, so let's say you have a y-intercept that's like 0.5, that means you had a vertical compression by 0.5. So your fraction is a compression, your whole number is a stretch. Okay, next problem. Describe the transformations. So if we were to graph this one, this is what it would look like. So it looks super, super similar. So probably the only thing that changed is your y-intercept because there's no reflection. So let's go and find our a value. Horizontal asymptote is y equals 0, so we're good to go with our intercept. Our intercept is 0, 3. So this means our a value equals 3. Our a value equals 3. That means what happened was there was a vertical stretch by 3. Now, if your horizontal asymptote, if that moves, that means it shifted up and down. But we're just really dealing with our stretches and compressions and reflections. Okay, let me know if you guys have any questions over that. That is the end of our notes for today.